You hurt yourself? Oh, nice. All right, y'all. So we're going to keep on moving with. All right. So quotient rule isn't too bad. It is a little bit more complicated than the product rule, but only because the formula for it is just a little bit larger. Let's see. Ooh, no whiteboard markers today. Interesting. All right. So let's just put our quotient formula up here. There we go. Make my pen a little bit thicker there. There we go. All right, so for our quotient rule, if we are taking the derivative of a function f over g, then that's equal to the derivative of the top times the bottom minus the derivative of the bottom times the top. And that is all over the denominator squared. And we don't do anything to the denominator when we square it. We don't take its derivative or anything. That's just what it is. All right, so we've got x squared plus 1 over x plus 3. So the top function is going to be our f. Bottom function is going to be our g there. So we can start off by making just a little list of our functions. And if you're really quick with derivatives, this isn't like a 100% necessary step, but it does make it a little bit easier to digest. So if our top function is x squared plus 1, then our first derivative would be 2x. And then if our bottom function is x plus 3, then the derivative of that would just be 1. So this one shouldn't be too terrible. So once we've got all that set up, remember that the quotient rule is really just like taking two derivatives. The only derivatives we take are of that top and bottom function. So really the only like calculus we had to do was to differentiate f and to differentiate g. Once we've got those four functions right there, all we're doing after that is just plugging them in and reducing. So it's really not like a huge process. It's just kind of a couple small derivatives built up into one. Okay, so f prime is 2x, and that's multiplied by g, which is x plus 3. And then we're subtracting off g prime, which is just 1, multiplied by f, which is x squared plus 1. And then it's all divided by our denominator squared, so that's x plus 3 quantity squared. So I think, so I finished working on the exam key today. There is one problem on there where I ask you not to reduce because it's kind of a pain. But for something like that, where you can kind of easily multiply it out, I don't think it's a big ask for you to reduce that. You're really just doing a little bit of multiplication. So let's check it out. All right, so in our top portion here, we'll have 2x squared plus 6x, that's 2x times x plus 3. And then we've got minus x squared minus 1 divided by, same thing in the denominator, x plus 3 squared. And one thing to note here, and this is, and I know that I keep harping on this, and if this is obvious to you, then hey, that's all right, you're one step ahead. Just remember when you're doing the quotient rule, you will see, even if you just look at like the original formula for the quotient rule, you will see g of x pop up in both the numerator and the denominator. Unless you have an x plus 3, however, in this part over here, then you can't cancel anything out. So if you just have like a product divided by another product, so a bunch of stuff multiplied together, divided by some other stuff multiplied together, cancel out at will. But when you're separated by a plus or a minus sign, remember that you need factors in every single one of those terms for that bottom term to cancel out. So we're just going to leave those alone, and we're just going to worry about the numerator. So up top, we are left with, there we go, x squared plus 6x minus 1. Divided by x plus 3 squared. Now, sometimes, every once in a while, your numerator might factor. It doesn't happen very frequently because, I mean, that's just kind of hard to do. Your numerator is a product and difference of 4 different functions. So if you get it to factor, great, but I'm not really looking for that. That's probably about as good as you're going to get it. So that would be all you need to do on that one. All right, anything I did up there that looks weird, looks incorrect, anything up there that looks really, really great and has improved your mood? Well, I think it looks great, so improved my mood. All right, got a couple more of these. There we go. All right, so same game. As soon as you see that big division sign, just start thinking quotient rule. So we've got a pretty simple function up top, just a regular old x, divided by not too bad of a function down there. But one thing that's different about this problem, and it doesn't seem like just looking at the problem that it's going to be any different than anything else that we've done. But when you look at that g of x, that's something that we're going to have to use the product rule on to take the derivative. So we'll have to do the product rule within the quotient rule. And I know that it's a little bit painful, but that's just something we're going to have to get used to, in that like when we learn different derivative rules, they don't just exist like, here's just the product rule, here's just the quotient rule. They're going to get intermingled together, and it's just going to get a little bit sticky sometimes. So for something like this, definitely take your time and write out your derivatives. So fortunately, f of x isn't too bad. I mean, f of x is just equal to x. So f prime would just be 1. So at least that's not bad. Now, g of x, that's going to be a little bit problematic, but we can handle it. This would be a good example of a problem where we're probably not going to reduce. And then just to remind y'all, yesterday we saw something like this. Remember, if you see a square, yeah, you've got to FOIL it. Well, actually, you have 2 choices. So you have a couple different choices if you'd like to differentiate g, which you're going to need to do. We can either multiply it out now and then differentiate it, or we could use the product rule on it in its current form and then multiply it out. Now, which one's going to be better? They're both relatively about the same amount of work, but since we haven't really multiplied it out first yet, we'll take a look at that and see what happens. So if you're doing the product rule on those two, we can talk about that as well. But for right now, I'm just going to multiply these out. And it'll create a little bit of pain when I do this because we've got a few different terms. But the advantage is my derivative is going to be a lot easier. So it really is kind of like a personal choice. All right, so multiplying this out takes a little bit of work, but not a whole lot. So there's our first part, and then taking the negative 7x through. And then our last part, here we go. All right, so nothing too bad. So we've got 16x to the fourth, and then our x cubed, we've got negative 56 of them. And then I've got, let's see, 32 plus 49 x squared. So that would be 81. And then my x's, I've got 56 of those. And just 16 hanging out on the end. So remember, I haven't differentiated anything yet. That's still just g of x. But now that I've got it in this nice polynomial form, the derivative's no problem. So for its derivative, we would have 64 x cubed. 3 times 56 is 168. And then we're subtracting 1 from the power. So in each one of these, this is just a review of the power rule. We're bringing the exponent down, multiplying it by the constant out in front if there is one, and then subtracting 1 from the exponent. So then we've got 162x minus 56. So the 56 just has a x attached to it, so we drop off the x. And then for the constant, derivative of a constant is always 0. So we've at least got the components that we need. And now we can start to plug in. Okay, so I need f prime g minus g prime f. I am doing quotient rule. Okay, so f prime is 1, and that's, yeah, plus that whole thing, so, yeah.
Minus x times 64
That's right. So minus x times the derivative, which is the 64x cubed expression. So this is going to be a pretty long one. This would be a good example of something that I would leave in unreduced form for the exam. Yeah. So what happens when you square a square? What would your exponent be? Yeah.
Is it that you add them or multiply them?
You multiply them together. So in our denominator, g is already 4x squared minus 7x plus 4 quantity squared. So remember from your exponent rules, when you apply an exponent to something that already has one, you multiply the exponents together. So in the denominator, we would have 4x squared minus 7x plus 4 to the fourth.
That's when you raise it, though, whenever you multiply